Okay, one thing about this coding activity, normally we don't really care that much whether it's Firefox or Chrome or Safari or whatever you're using. For some reason, this thing works better in Google Chrome.
Oh.
So if you're on a Chromebook, you're great. If you're on a Windows or a Mac, you might want to open up Chrome instead of Firefox. The text looks a little bit out of place if you don't do that. Anyway.
What about Safari?
I haven't tried it in Safari. I don't know. But I know it works in Chrome. So
That's something you guys can do out there for all you guys who have a Safari browser. Try it out. Does it work on Safari? If not, you can always do Chrome.
and if somebody wants to look at the code and figure out why it works differently in Firefox and Chrome, let us know. So I forget if we're at step 2 or step 3.
Let's see, step 1.
All right, so we did that part.
Step 2, calculate the average, yeah. And then
Step 3, here we go.
open up the editor.
Yep. So that's going to come up there. Now the first thing, what's the first thing you do when you open up the code? Do you remember?
It was to, do this.
Yes. Everybody forgets to do this, but it's super useful. So Liz, why don't you take, Liv.
He did it
Gosh.
again.
Gosh.
He did it again.
Did it
Shaming.
again.
Shame him.
Olivia, why don't you take a look at the code and kind of see what's there? And then also, we got to make sure to update these values.
Oh, thanks, Jeremy. I'll just call you Jeremy from now on. All right. So, sorry, I was too busy, thinking about what alternate name I would call you. What do you want me to do?
I don't know. Take a look. Yeah, so let's maybe we'll do a Control Plus so we can see the code a little bit better. But let's just kind of take a tour of what's here. We don't have to understand the whole thing, but let's just kind of see what's here.
All right. So it looks like we have some values. We have our Tmin, which is already plugged in here, and our Tmax, and the values for that's average, and then T average. Could you explain these two lines of code right here for us?
Sure. So T average, this is going to be the average temperature of the year. So the average temperature in Columbus over the years, I don't know, what is that, 55 degrees or something like that?
Yeah.
So if you add those two things together, divide by 2. So we're going to need this average later on. So we're going to go ahead and compute it straight up. And then this is the amplitude of the temperature variation. So it's how much does the temperature change to the year? So it's the difference in those two things instead of adding them together.
Awesome. And then, of course, year, 365 days. T warming. Whoa. Currently a 1.4 Fahrenheit increase in global average temperature. Why is it 0 right now, Jeremy?
So we're going to start out with, so this is how much the global temperature has increased. And so every time we run the draw function, we're going to increase that shift, that global shift in the average temperature. But we're going to start off with 0. So in other words, we're going to start off with everything kind of being normal. And so if you press play, the line that you'll see for the normal color is going to be green. So everything's happy and green because it's Earth, Earth Day, things like that. But as things get hotter, this red line is going to show you as the temperature increases. So that's the idea of it.
All right, now getting into the draw function, we have our first two variables, which designate average days below freezing. We got temperature array, temperature for global warming array, and then a for loop here, which it looks like. What does it look like, Jeremy?
What does it look like? So the temperature through the year is going to be the average temperature plus this kind of cosine function. And so it's going to calculate that and set that. So each one of these so for each day, it's going to calculate what the temperature would be. And if you look closely, there's a time variable here. And so depending on what day it is, it's going to tell you what the average temperature of that day is.
All right, you can tell I rehearsed. And we have display and then some output. All right, so I think we're ready to get started.
Yep. Now, that one thing, got to highlight this one.
Oh, yeah, what's this? The T warming? Oh, yes. It looks like the next time we actually increase global warming temperature. So every time that this line of code is hit, it is going to increase the T warming variable by 0.01.
Right. So go ahead and press play. Let's see what this thing does. There we go. So you see this kind of, you can barely see this green line under here. The green line's not going to change. The green line is sitting there doing the same thing. But the red line, and maybe I'll do that so people can see it. The red line is going to kind of steadily increase. You see how the temperature is going up, so it's 2.3 degrees Fahrenheit, 2.4 degrees Fahrenheit. And what you're seeing is that the number of days that the temperature is below 32 degrees Fahrenheit gets smaller and smaller and smaller and smaller until the average number of days of freezing weather gets to be 0. Now that'll be far in the future, but what we're trying to do is try to figure out now with the 1.4 degrees Fahrenheit shift, how many days of freezing have we already lost? If that makes sense. So go ahead and hit stop, and then maybe do a control minus so you can see more of the sketch. There we go.
And play again?
Sure. So what you want to do is, well, we want to do two things. So first of all, we want to pay close attention to when this thing gets to be 1.4, how many days have we lost? So it is about 14 days according to this estimate. Okay? So that's 14 days of the year that under normal circumstances you would have freezing weather. And so ice can, you can have ice, you could have snow on the ground. But because of global warming, you don't have those 14. There's 2 weeks of the year that's, that you can't form ice in. So if you're a snowman, that's 2 fewer weeks that you're going to be able to survive. So that's bad news for snowmen.
Oh no, Olaf.
Yeah, Olaf. Sorry, dude. 2 weeks fewer. Good weather for you. So the idea of this whole thing is that what you should do is you should find the temperatures of your location from the climate data thing, put that into there, and then as the temperature shifts, you can see how many of those days of freezing are you guys missing? Okay. So if we go back to the tab here, there's a few other things worth talking about. Now, I don't know if you noticed, but the temperature from day to day sometimes can sort of randomly change, right? So,
oh yeah.
So today it's a certain temperature, tomorrow might be a totally different temperature. And there's trends and stuff like that, but the plot that we just did is not very realistic. So why don't we modify the code to make it just a little bit more realistic by putting in like a random function for how the temperature kind of fluctuates through the year. Make it more realistic.
Yes.
Can you do that?
Sounds fantastic. All right, and it looks like our equation looks like this right now.
That's correct.
And so
that's correct,
what
Olivia.
We'll do, thank you, Christopher. And here, this function will give us a random element. So if I remember how this works, it'll just basically give us a random number between -10 and +10. So we're going to add this in. Just going to take that because I will forget. And we're going to locate where we're changing the temperature right here. So we're going to change this, and we're going to paste that in.
How did you paste that?
I actually did use keyboard shortcuts this time. I used the typical control V. Wait, Yeah, no, Control V to paste, and Control C to copy.
Yep.
And, all right. And so unless Christopher has anything else that we need to add, I think we can play it again.
Yeah, let's see what it does. I want to see what the realistic version does.
Wow.
So now it has all these, and if you look at a real chart of, the temperature data from your city, it's going to look a little bit like this, right? One day it's going to be cold, the next day not so much. And so now you notice that, now that we're at 1.8, 1.9, the number of days of freezing that we've lost, it's going to be fluctuating, but it's still going to have this kind of trend. And so we're still going to lose a significant number of days because of this overall shift. So there you go. So it's kind of, it's kind of tricky to show that. The reason that I think that this is kind of an interesting coding activity, and maybe you can agree with me or not, is that 1.4 degrees Fahrenheit, like, not a big shift, right?
Yeah.
Like, if you increase the temperature of my house by 1.4 degrees Fahrenheit, I don't know that I would notice.
Yeah, same.
Yeah. So it doesn't seem like a big shift, but the thing is that the effect on the number of days of freezing, is pretty big. So one of the cool things that you can do as a kind of an add-on to this activity is that you can go here. So if you go down to the bottom, so one thing you could do is go to AccuWeather and look that up. So don't do that right now. But if you go down to the bottom where it says compared to published estimates for the impact of climate change at your location. Now we're lucky in the Midwest because there's this research center that has thought about this, and they've released for individual cities kind of what the impact of climate change might be. So if you click on, either on this link, which is just a picture, but if you click here, now not everybody's in the Great Lakes, but if you do some research, you can kind of find
this link.
That one, yeah.
All right.
So it's going to bring that one up, and you want to click on Columbus there. It's great if your city is on there, but you might have to do some more research. Then scroll down to the bottom of that, and then click on the PDF. So here they have this kind of temperature, average temperature per day. So if you're going to go down to the bottom of this page, so there it is. So there's the average temperature through the day. And this is kind of before global warming really starts to kick in. And then they think about, how does it affect the temperature? How does it affect the rainfall? Things like that. And a cool thing is if you go up for a little bit, you see where it says longer freeze-free season? According to their estimate, Columbus has lost 25.5 days of freezing weather.
Great.
Right. But so one thing is that, my parents went to Ohio State back in the 70s, and apparently, some of the rivers would freeze over. People would walk across the river. They would ice skate on rivers.
Wow.
It was so cold because they had 25 more days of freezing, basically. But this is something that you can do at your location. You can kind of try to hunt down the data for your location and try to see how does your program compare to that. And so maybe if we turn off the randomness, if you just want to comment that out.
Before.
Yeah, do you want to just comment that out, the random part?
Yeah, sure. So just this entirely, or add in what was already there before?
If you just want to comment out the last part of that and put in a semicolon, if that makes any sense.
Yeah.
There you go. Yep, and just put a semicolon there to end the line. Now, one thing you might want to be aware of. So, I actually grew up in Florida. So my parents grew up in Ohio, and then they moved to Florida because they wanted to get away from the amazing number of freezing days that we had in the 70s. So in Florida, Florida I don't think has days in the year that it's freezing, and so the number of freezing days it would normally have might be 0. Maybe there's people out there that are watching from some tropical location or something.
I'm so jealous.
Yeah, so, what are you going to do for estimating? Like, so how is this code going to estimate the impact of the warming climate on your location? Well, what you can do is you can just change this from being like 32 to like 50 or something like that, and you can count, how many fewer days of 50-degree weather that do you have? So that's another thing that you could potentially look at if you live in a warm place. So let's go ahead and hit play, and again we are gonna now the other thing that I want to say real quick is that I found interesting from this PDF is that they said, not only did they say it was 25.5 days, they said that in Columbus the average temperature warmed by 2.3 degrees Fahrenheit. Okay? So globally it's a 1.4 degrees Fahrenheit shift, something like that. But in some places are going to warm more and other places are going to warm less, right? Because that's the average. And so they noticed that 2.3 degrees Fahrenheit is 25.5 days. So when we watch this thing, you want to set it loose again?
Yeah.
How many days of freezing weather do we lose by the time that this gets to, what is it, 2.3 did I say it was?
Yeah. Or
yeah.
3.2?
I think it was 2.3. So, all right, so at 1 we've lost 10 days. 1.4 we lost 14 days. Here we go. 2.3, almost exactly the number of days that they said.
Oh, awesome.
I don't know what I'm doing. I'm not a climate scientist. So our code totally matches up with this number.
Ah, cool. There you go, 3 a.m. working on this code, Chris, and you did it.
So it's not that hard to make a computer program that can kind of help you understand how the climate works and what the impact of a warming globe would be. And in order to understand how we're going to fix it, we have to understand the effect to begin with. So we hope you enjoyed this video. I want to thank Olivia, a.k.a. Liv.
And not Liz. My name's not Liz.
No. I want to thank her for coming out and helping with the video today.
And I want to say thank you for having me.
Great. And good luck on finals next week. So.
Oh, yeah. Thank you. And
Godspeed.
Good luck on grading stuff if you have grading stuff to do.
Yeah. Cool. Happy Earth Day, everybody. So what do you think of that?
Oh, that was good.
Good?
Yeah.
Cool. Was it good enough?
I don't know.
You probably need to get going. Okay.
No, I think it was good enough. I know you're a perfectionist.
I am a perfectionist.
I'm just like, well, did we say words that were good? I didn't say a curse word on camera. That's good. At least not a part that would be fast forwarded. All right, that's my bar for if it's good.
Okay. All right. Sounds good to me.
We said get here at 2:15, so I get to bill you for like an hour and 25 minutes. Woo!
Well, I don't know that they set up the employment thing. Did you fill that out thing, or I can get you a gift card of some kind, but.
When I go to fill out my stuff for my my grading position, it comes up too. It's like, oh, Civilati Paul, oh, Orban Christopher, and then...
That might have just been the gift card, though. Just saying.
It's on like when I go to fill out timesheets, it's their timesheets. And it's like, oh, you haven't filled out a timesheet.
Yeah, well, go ahead and fill that out then.
Yeah, and see if it works.
Yeah, I can try to climb around and hit pause on the recording thing so we don't take up Scott's.
Oh, yeah.
I think